Welcome to our demo session on the Voxel Layer API for the Pro SDK for .NET. We'll start with a brief overview, followed by a more in-depth look at voxel layer creation, voxel variable profiles, and then looking at isosurfaces, slices, and sections. Voxel layers were added at 2.6 and the API followed at 2.7. To use voxel layers in the API, you must have a Pro Advanced license level. Voxel layers can be used to visualize NetCDF volumetric data. When creating a voxel layer, you must use a NetCDF file as your data source. Voxel layers get added to local scenes, and the local scene must have a coordinate system that matches the coordinate system of the voxel layer. Use the standard layerFactory.instance.createLayer call, the templated type, in conjunction with a voxel layer creation params. Working with the voxel layer API requires an advanced license level. To create a layer, we have to add it to a local scene. To create a voxel layer, I create a voxel layer creation param passing the path to my NetCDF data source as the argument. With the voxel layer creation params created, I can customize the data that I want included from the dataset in my voxel layer. For example, this particular dataset contains 4 variables. To exclude unwanted variables, I simply set their isSelected property to false. Additionally, you can specify one of the variable values to become the default by calling setDefaultVariable with the specified variable on the create params. If you don't change the default, then the first variable will be selected. The voxel layer is created and is added to my TOC. In this particular case, the voxel dataset represents water and salinity concentrations in the Atlantic. Voxels can have multiple data values associated with them, and they are stored as variable profiles, more specifically as voxel variable profiles. Their data type can be either continuous or discrete. If it's continuous, it will be rendered with a stretch renderer. If the data value is discrete, it will be rendered with a unique value renderer. There is always one voxel variable profile that is the active or selected variable profile. And as you'll see, when you change the selected variable profile, the renderer of the layer is changed. You access the available variable profiles off the voxel layer. Let's look at working with the voxel variable profiles. I access the available variable profiles off the voxel layer with getVariableProfiles. The active variable profile or selected variable profile is available in the selected variable profile property. Currently, that variable profile is called salinity. In this code here, I'm simply picking all of the variables that are not selected, randomly selecting one of them to become the new selected profile. As I only have one other variable profile in this case, water temperature, this code will simply switch the selected variable profile to that one. Notice that when I change the selected variable profile, the rendering of the layer also changed. That's because the renderer on a voxel layer is associated with the variable profile, water temperature in this case, and not with the layer. If I change the variable profile back, and this time I'll run the same code but without a breakpoint, notice that the renderer changes back. The voxel variable profile has now been switched to salinity, and its renderer is being used to display the layer. On voxel layers, you can create isosurfaces. An isosurface is a surface that represents a single data value within a voxel variable profile of continuous data type. You cannot create surfaces for discrete data types. Every voxel that is visualized in an isosurface will have the same value. So the isosurface is homogeneous. You can create up to max number of isosurfaces per variable profile. That limit is currently set at 4. To manipulate isosurfaces, you use something called an isosurface definition, and you access the isosurface definitions off the variable profile and not the layer. To create, update, and delete isosurfaces, you use the desired surface definition, calling create, update, or delete isosurface respectively. Let's look at how to work with isosurfaces. Isosurfaces are associated with a voxel variable profile, not with the layer. I'm accessing the currently selected voxel variable profile. The visualization mode must be surface. I call canCreateIsosurface on my currently selected profile. canCreateIsosurface checks the following criteria. The visualization mode is surface. The max number of isosurfaces has not been reached. And the current profile is continuous and not discrete. If all of those criteria are met, canCreateIsosurface returns true. To work with an isosurface, you use an isosurface definition. In this case, I am creating an isosurface, so I'm going to define a new isosurface definition. I'm setting as the value for the isosurface the midpoint of the current color range. Notice I access the color range off the renderer, and in turn, I access the renderer off the variable profile and not the layer. Renderers in voxel layers are associated with the variable profiles. I assign the value to my isosurface definition, I give it a name, and then I call createIsosurface to create it. Here's the resulting isosurface. Every voxel that is displayed in this isosurface has the same data value, in this case 34.02. To update an isosurface, I can retrieve the available isosurfaces off the variable profile with get isosurfaces. I'm simply returning the last one, which in this case is the one that I just created. I now have the surface definition. I am incrementing the value by 1 unit. I assign the change with update isosurface back to the current profile. If I wanted to delete the isosurface, I would call delete isosurface with the surface definition. Notice the value of my isosurface has now been changed to 35.02. And of course, because the value has changed, so has the color. Let's look at slices and sections. Slices are used with voxel layers to define an area of interest. A slice slices or cuts the voxel volume, essentially filtering out the data that has been sliced. This can be useful for viewing a subset of the voxel data, especially when the voxel datasets are large. Slices also have the added benefit of revealing the internal structures of the voxel volume. Use sections to define vertical or horizontal two-dimensional planes that cut through the voxel volume. Whatever is the current symbology of the layer at the time that the section is created, that will be the symbology of the section that the section uses. However, you can lock sections to create permanent snapshots that cannot be edited. So if the symbology of the layer changes, for example, the symbology of the locked section will remain the same. To define a slice and section, you use something called a slice definition or section definition, respectively. They require 3 things: location on the voxel layer in X, Y, and Z in voxel space, that is, in the coordinates of the voxel, an orientation specified as an azimuth from 0 to 360 degrees counterclockwise from north, and a tilt describing the vertical angle ranging from 0 degrees to plus or minus 90 degrees, 0 degrees being vertical. Note, the orientation and tilt must be converted to a unit normal vector when it is applied to the slice or section definition. You can use voxellayer.getNormal to convert the orientation and tilt to a unit vector normal, and get orientation and tilt to convert the unit vector back. I've put together an animation to help reinforce these points. Recall, to define slices and sections, we need 3 components: a location, an orientation, and a tilt. The location is specified in voxel space. The location can be anywhere within the volume, and it can be anywhere along the face or the plane of the slice or section being defined. The orientation is an azimuth from 0 to 360 degrees, expressed counterclockwise from north. The slice or section being defined will be extended in the XY plane along the specified orientation and will completely bisect the voxel volume. The tilt is the angle from vertical, expressed as an angle from 0 to positive or negative 90 degrees. Specify a positive angle to tilt the slice or section forwards, and a negative angle to tilt the slice or section backwards. The angle of 90 degrees represents a horizontal plane. Same as with orientation, the slice or section will be extended in Z at the specified tilt to completely bisect the voxel volume. Let's review this process looking at some code. We need a location, orientation, and tilt. The location in voxel space, the orientation as an azimuth, the tilt as an angle, 0 to plus or minus 90 degrees. To create a slice, define a slice definition, provide it as the argument to create slice. Specify your location in voxel space, the orientation and tilt as a unit vector normal, and of course you can use get orientation and tilt to translate the unit vector normal back. The slice will define an area of interest that will cut or slice the voxel volume. There is no limit to the number of slices. And you can use update slice or delete slice with the specified slice definition to update and delete slices, respectively. Create section follows the same process as with slices. Define a section definition using a location, orientation, and tilt. Provide the section definition as the argument to create section. Define the section definition with the voxel position and the normal, same as with a slice. The resulting section will define a two-dimensional plane that cuts the voxel volume. It will use whatever is the current symbology of the voxel layer, and there is no limit to the number of sections that can be created. To preserve the symbology, location, orientation, and tilt of the section, you can lock it to create a permanent snapshot. Use update section and delete section with the respective section definitions to update and delete sections, respectively. Let's look at creating and updating slices and sections. To create a slice, we need to specify three things, same as we discussed in the slides: a location, an orientation, and a tilt. My location must be in voxel space, my orientation an azimuth 0 to 360 degrees counterclockwise from north, and a tilt 0 to plus or minus 90 degrees. In this case, I'm specifying an orientation due west 90 degrees and a vertical tilt angle of 0. I'm creating a slice, so I define a slice definition. I provide the location, and I translate my orientation and tilt to a unit vector normal. I apply the slice definition to create slice, and here is my resulting slice. To update the slice, I can retrieve the available slices off the voxel layer with get slices. In this case, I'm selecting the first, which is the one that I just created. I am going to change its orientation by 10 degrees. I translate the vector normal, the unit vector normal, back to an orientation and tilt. I increment the orientation by 10 degrees, translate that back to a unit vector normal, and I call update slice. Notice as I update the slice, you can see its orientation is changing each time by 10 degrees. To delete the slice, I retrieve the slice definition and I simply call delete slice. Let's look at creating sections. Same as with slices, I define a location, orientation, and tilt. Instead of defining a slice definition, I define a section definition. I specify its location, I specify its orientation and tilt as a normal, and I apply it to create section. The resulting section creates a 2D plane that cuts through the voxel. To update the section, I retrieve the available sections from the voxel layer with get sections. In this particular case, I'm retrieving the first one, which is the one that I just created. I am translating its normal back to an orientation and tilt. I'm incrementing the tilt by 10 degrees. I'm applying that tilt to each section in get sections. I currently only have one section. I translate the orientation and tilt back to a normal. I apply that to the section definition and I call update section. The tilt has been changed by 10 degrees. To delete the section, I retrieve the desired section or sections and I call delete section with the specified section definition. In the API, I'm not restricted from only creating sections or slices one at a time. I can create multiple. For example, here I'm creating 3 sections, 2 that bisect the voxel vertically, and 1 that bisects the voxel horizontally. In this example, I'm creating sections in a circular pattern. Each section is spaced 12 degrees of orientation apart. In this example, I'm creating sections along a diagonal, regularly spaced across the voxel. The same is true for update. I can update multiple sections at one time. And of course, the same is true for delete. That concludes this demo session. I hope you found it useful, and thank you for your time.